Okay, we want to add the two vectors with r equal to 2 and theta equal to 30. And we want to add that to the vector with r equal to 2 and theta equal to negative 60. Now, to do this, we're going to switch over to rectangular coordinates. All right, so we need to remember some of our things about rectangular coordinates. All right, our first formula, let's just use y equals r times sine of theta. And we can fill in y equals 2 sine of 30 degrees. And if we put that thing into our calculator, that is going to give us 1. And then let's do the same thing for our x. X is r times cosine of theta. And so that gives us x equals 2 cosine of 30 degrees. And if we put that into our calculator, that gives us the square root of 3, which turns out to be 1.732. All right, now let's do the same thing for this vector here. Y is going to be 2 sine of negative 60 degrees. And that's going to be negative 1.732. And x is 2 times cosine of negative 60 degrees, which is going to give us 1. All right, so here we have, if we put this into our notation, our electrical notation, 1.732 plus 1j. And over here we have x is 1, so 1 minus 1.732j. And to add these together, we're just going to add the components. So I'm just going to line them up. So I'll add the numbers to the numbers here. That's going to be 2.732. And the 1 plus the negative 1j gives me negative 0.732j. Now let's switch this back to polar coordinates since we began in polar coordinates. So let's remember this first value is our x. This second value is our y. If we go to our formula first to find r, we need to fill into this formula. So that's 2.732 squared plus negative 0.732 squared equals r squared. And that gives me, when I put that left side into the calculator, 7.9858 is equal to r squared. Take the square root, and we get that r is about 2.83. All right, now we still need to find theta. So remember, theta is equal to tangent inverse of y over x. In this case, our y is negative 0.732. And our x is 2.732. And if we put that thing into our calculator, that gives us approximately negative 15 degrees. So this, if we write it in our new notation in polar form, is 2.83 angle negative 15 degrees.